Okay, here we are for today's video, which is about compound interest. Alright, so this is probably, of all the videos I've done, the most narrow topic of all of them. It's just about this one kind of problem in this one formula that goes along with it. Alright, so what I thought I would do is I'd tell you is in the simplest way as I can what compound interest is and how it works. And then you'll have just sort of a basic understanding of it without going too far into the details. All right. And then when I give you this formula and I do some questions based on the formula, you'll sort of have this going on in the background. All right. So let's do it in that order. First, I'll tell you how it works, what it is, and then second, we'll talk about how you actually do the math. All right? Okay. So as far as compound interest, how it works, what it is, here's the basic process. I've oversimplified it a little bit from how it might actually be, but this is more or less how it works. This is the big picture. All right? So say you invest or borrow some initial amount of money, and we'll call it P. All right? You can invest it, and if you invest money, it hopefully would earn some interest. Or if you borrow money, you're gonna have to owe some interest, but there's gonna be interest involved in an investment or in borrowing money. So, say you invest or borrow some principal amount P. Then from there, we'll calculate interest on that principal, and that will be based on an interest rate. Okay. And then here's what makes it compound interest. We'll add that interest back to the principal, and then we'll repeat over and over. This aspect of adding the interest back to the principal, that's called compounding the interest. Okay? So you might think of it like this. I start with some initial amount of money, P. I calculate the interest from that amount. I add it back. Now this amount's bigger. So when I calculate the interest the next time, it's bigger. And I add it back. And now this is bigger. And now the interest is bigger. And I add this back. And so it just grows over time because you're adding the interest back into the principal, calculating the interest again, and every part of this just gets bigger and bigger and bigger as you keep going. All right? So that's the simplified version of, but still true, still accurate. This is what happens. But I didn't do any math. That's why I'm saying that this is simplified. Okay? So what's the math going to look like? All right. So we have this formula right here that will do the math for us. Okay? And the formula, I take it at face value. I just want to tell you what every part of it is. Okay? So you see that capital P? That's the original principal that we invest or borrow. Okay, so that's what I was talking about up there. R is the interest rate. And that needs to be, for the sake of this formula, that needs to be a decimal. So what I mean by that is, if it was told to us that the interest rate was 8%, then for the sake of calculation up there, I would use the number 0.08. Okay? 8%, well, percent means parts out of 100. So 8% is 8 over 100. So our number for calculation then is 0.08. That's what you'd get if you divided 8 by 100. Okay. N is the number of times per year the interest is compounded. So it might be that you compound, you see this part right here? Calculate the interest, then add it back to the principal. It might be that you do that every month, like for a mortgage. When you make your payment, the interest is also factored back into the principal. All right? So anyway, okay, so N is how many times per year the interest is compounded, as explained up there. Monthly would make N be 12, for example. Quarterly would make N be 4. Okay? T is the duration or the length, however you want to think about it, of the investment in years. In A, this number, what you get when you do all that math right there, that number A is the original principal that you started with, plus all the interest that was earned along the way. Okay? All right. So that's a like bird's eye view of the formula, bird's eye view of how compound interest works. Okay? So let's see what form this might take if we're doing problems. So I have a few sample problems for you. So Gart, consider this one. How much money will there be in an account at the end of 8 years if $7,000 is deposited? It earns 6% interest compounded semi-annually. Okay? Well, I showed you that formula, all right, on the last slide, and that was like so. And I guess we'll just have to, I don't know, out of the context of this formula, we'll have to figure out what everything is. Okay? So this, how much money will there be, that's going to be this A number. Okay? $7,000, that's what we start with. 6% is the interest rate. Semi-annual, that would mean we would compound the interest twice a year. So that would make N equal to 2. And T, the length of the investment, the time the money is left to cook and earn interest, that's going to be 8 years. All right. So I'm going to find A, the grand total after all the interest is earned, based on investing $7,000, R 6%. Remember how we have to write that? I need to write 6% as a decimal, so 0.06. N's going to be 2. Compounding semi-annually means we're compounding the interest twice a year, so N is 2. And this is going to be 2 times 8, right? How long do we invest the money? 8 years. All right, so T is equal to 8. So there's everything. Now, we just have to do this in our calculator. I'll probably take the strategy of doing one thing at a time. Like, say in my calculator, I'll probably do it like this. 1 plus 0.06 over 2. Let's just figure out what that is, right? That would come first. Okay? All right. I raised that to the power. That power is going to be 16, but if, say you wanted to type it in, we'd do like that. All right, the power is 2 times 8. All right, so I get like so. And then I take that number and I multiply by 7,000. So times 7,000. Okay, and there we have it. So it's be about 11,232. And I think for these, it will make sense to round to the nearest penny. Okay, so I'm going to say 11,232, and let's do like 95 cents. That decimal is 0.945, so if rounded to the pennies place, right, the second decimal place, that'll be 95. All right, there we go. So I think with a calculator, that formula, not that hard to use. All right, let's try another one. Okay, this one. So $10,000 is invested, 9% interest, compound quarterly. Calculate the interest that's earned in 15 years. Okay? So say that I went about it like this. Say that I think it's like that last problem, where of course I would use this because this is our formula for calculating compound interest. I realize that 10,000, that's of course the amount I'm investing. My rate, 9%. That's R. 9% is going to be 0.09. Compound quarterly. I'm compounding the interest 4 times per year. That makes N equal to 4. Okay? And then this power is 4 times 15. N is 4. T is the length of the investment in years, and that's 15 years. Okay. Say I do like this. Say I do this. Okay. So I'm going to do it like I did the last one. I'll take 1 plus 0.09 over 4. Okay. I'll raise that to the power of 60. But if you want to type it in, just make sure that you would use parentheses like that. Okay? All right. Now I need to take that number times 10,000. And this is that, right? So I could say A is, with some rounding, I'll round again to the nearest penny, 38,000 and $1.35. All right. Okay. So then it seems like we get our answer, right? But what did it ask for? It asked for the interest that we earn. Let me go back and remind you about something. When we use this formula, what's that number that we get right there? That is the original principal that we started with, plus all the interest that was earned along the way. So when I see this number, I think, well, that's the principal I started with. That includes the 10,000 plus all the interest that I earned over 15 years. So what's the interest? Like, how much interest did you get? All right, we look at it like this. If I started with 10,000 and it grew to 38,000, then if I took 38,000 minus 10,000, that would be the interest. All right? So we'll just make one more step. The interest is equal to A, which is this number, minus the 10,000 that we started with. That would be just the interest. Okay, so I still have my number in my calculator. It'd be real easy, calculator or not, to just subtract 10,000. And there, that's how much interest I got. The interest is about 28,001 and 35 cents. Okay, so that's what we were after. Again, I rounded it to the nearest penny. All right. Okay. I can't say that's the interest because that includes what I started with. The difference between these is the interest. All right. So let's see, 2 down. Let's go to question 3. All right, so check out question 3. So this time, it seems like we have all the same pieces, all the same ingredients as the other problems. We have a principal that we're starting with, and apparently that grows to $15,000. Okay, so 10,500 grows to 15,000 with an interest rate of 8% daily compounding, but we don't know how long it takes. So that's the question. How long does it take for this initial investment to grow to that amount at this rate and that compounding? All right, so we're looking for the time here. But let's, like the others, let's start with our formula. Here's our formula. All right, this somehow must be in play. That's how it works, right? Okay, now let's fill in what we have, and then we'll figure out some way to work through this. Okay, so I end up with 15,000. That's what this number is. That's what you end up with after all the interest is earned. So we'll say 15,000. I started with 10,500. Okay. My interest rate, 8%. Of course, we use 0.08 for that. Compounded daily, you're compounding the interest 365 times per year. Okay. All right. Ends 365. So I get 365 up here times t. All right, so take a good look at that. Everything is in there. I want you to agree that I put all the numbers in the right place, and that when you do a question, you can put all the numbers in the right place too, at least to get started. That's how you get started. Okay, so how would we solve this? I'm trying to solve for the exponent. Okay, so how would I solve for the exponent? Well, our trick for doing that is going to be like this. I'll in fact give you an analogy real quick. So let's say, here's my analogy real quick. We'll pause that problem and I'll show you something else. Suppose that I had this problem. 8 is 2 to the t power. I mean, this is a simplified version of what I'm trying to solve on the other paper, okay? Now, the reason I give you this is because we should know the answer to that. Doesn't the answer have to be 3? Isn't 2 to the third power equal to 8? Okay, so I just wanted us to say, yeah, okay, we agree about the answer. But let me show you the technique that we're going to need for this one. All right. So here's the technique. We take natural logarithm, meaning logarithm with a base number of e on both sides. What exactly is that? Well, you could think of it as this function on my calculator. Me introducing this allows me ultimately to use my calculator to get an answer. All right. So say I do that, all right, and I just treat this equation that I can do the same thing to each side. If I apply natural logarithm to the left, I have to keep it balanced and equal by applying it to the right. All right, so what that would allow me to do, though, is take that power and move it out here like this. Okay, there's a rule for logarithms, that when you have a logarithm of a number to a power, that power can be applied there as multiplication. This says t times natural log of 2. So all I need to do to solve for t is divide by this number right here. Okay, so I'll get t equals this number, natural log of 8, over this number, natural log 2. Whatever that is, I guarantee you it will be 3. But like I said, this allows us a way to do things on our calculator. So natural log of 8 divided by natural log 3. Okay. Natural log 2. All right, I typed it in, and it tells me that that's equal to 3. All right, sure, I can see why. 2 to the third power is 8. Of course the answer is 3. All right, but this technique allows us to use calculator. All right, so now I'll need to do that here. This one, there's just no way I could do this in my head. I'm going to have to use the calculator. So here's how I do it. This one looks more complicated than this one, but I'll have the same basic procedure. First thing, I want to divide this number over there. Okay, just to consolidate these as one number. So that I get 15,000, okay, divide by 10,500. Okay, and I'll just go ahead and leave it like that. We might be able to reduce this down a little bit, but it's all going in my calculator anyway. So I will just leave it. Okay. All right. My next thing, I will do what I did here. I got a number equals to another number to the t power. I want to solve for the t. So I'll do this. Natural logarithm. 15,000 over 10,500 equals 2. Now when I apply the logarithm over here, that power, that entire power, whatever it is going to get moved. Just like that problem I showed you just a second ago. Okay, so now we get here. It is just like this one. Logarithm, bring power to the front. Okay. Now, I wanted to solve for t, right? Where it's right there. See the t? How would you solve for the t? This says 365 times t times that logarithm. So that's all multiplication. If I want to solve for the t, I'll need to divide by the 365 and divide also by this logarithm. And I'm not worried about what any of these numbers are right now. I'm going to use my calculator in the end. I'll divide by 365 and that. So that will get me the t, the time by itself, and give me an answer. So here's my answer. It's going to be that number right there. Okay, 15,000 over 10/5. Okay, over, what were we? We were going to divide by 365. Okay, so 365. We were also going to divide by this number right there, natural log 1 plus 0.08 365. Okay. All right. So that is my answer. That's definitely something that we'll use a calculator to figure out. Well, so let's see. Here's how I'll do this. Okay. So I'll figure out this top number. So let's do that first. Natural log 15,000 over 10,500. Okay. And so that ends up being like so. All right. Okay. Then I'll divide that by 365. Okay. And then I'll divide it by this logarithm. So I'll just hit divide again. Natural log 1 plus 0.08 over 365. Okay. Press enter. I get 4.45. All right. So we'll have to round that number. We'll just, when we're doing our homework or we see a question and we give an answer, we'll just round however it says to. So let's say I'll round to 1 decimal place, 4.45. That will be about 4.6 years, right? We're solving for the time. You're going to have to invest, oh sorry, I wrote 4.6, 4.5. We're going to have to invest that amount of money for 4.5 years, for it to become that. All right, that's how long it's going to take. All right, okay, so we could, any problem where we're solving for the time, we could take the same strategy and we can do it that way. All right. Okay, so let's see another one. Let's do, like, this one is kind of like the last one, although it might seem like there's not enough information to solve it. So let's read it, see if we can figure out that it is like the last one, and even if it doesn't seem like it, that there's enough information to solve it. Okay? Okay, so it says, how long in years and months will it take for an investment to double at 12% compounded monthly? All right, well, so I know my formula for compound interest. Whoops, I wrote P. So my formula is A, the amount after all interest is earned, is P, the principal, plus, or times 1 plus R over N. Okay, I'll get there. R over N to the NT power. Okay, so that's what we're going to use. Now, I don't know how much I start with. I just know that what I end up with is double what I started with, right? That's what it says. So how about this? We'll say, I don't know that number. I know this one is twice as big, though. So you invest P, but you end up with double that. All right? That's as much as I can do. It doesn't tell me how much you start with. What else? 1 plus the interest rate, 12%, 0.12. Compound monthly, 12. So that's 12%. If I compound monthly, N is 12. compound 12 times per year. 12t. It says how long. The issue is I don't know the time, right? How long? I don't know the time. I'm trying to figure it out. Okay. So, okay, I get that. Say I get that. Everything's set up. It might still bother you that we don't know what P is. We don't know what we invest. But it turns out it doesn't need to be known. The time it takes to double, it doesn't actually matter how much you invest. Here's why. Suppose I set it up with the information I have. This is double that, 12%, compound monthly. Notice that I could take this equation, I could divide the left and right hand sides by P. What happens over here? Cancels. What happens over here? Cancels. Okay? So I divided both sides by the same thing. P, the principal. What's left? 2. What's left over here? 1 plus 0.12 over 12. 12t. Did we see a similar one to this just a second ago? We saw 2 of them, in fact, right? How do you solve for that power right there? You introduce the logarithm. You can move the power down like that and divide. Or you introduce the logarithm here. You can move that power to the front and you can divide. All right? So yes, we have seen this. So I will do this. Natural log of 2 on the left. There's my introduction of the logarithm. That's what allows me to use my calculator with this function, that button right there, ln, the natural logarithm. Over here, ln 1 plus 0.12, 12t. I did that. I introduced it on each side. Now what can I do? There's a rule for logarithms. I told you about it already. I mean, I like to make the videos thorough, but I guess the way it may be in a book or on our formula sheet is log base b of some number m to some power p. You are allowed to move that power here and multiply by it. All right? Okay, that's what I can do here now. I have a logarithm of something to a power, right? So I get natural log of 2. This will be moved over here, 12t. This will remain what it is, to be calculated in a little while. All right, so I guess now we're only one step away from solving for t. All right, just one more thing. What's going on here? This is 12 times t times this logarithm. So if I divide by 12 and I divide by the logarithm, I solve for t. All right, so here it is. T is, right, we'll get that number, natural log of 2, divided by this number, 12, also divided by this number, natural log 1 plus 0.12 over 12. There's our number. Okay, calculator required at this point. So I'll do like so. What's natural log of 2? What's that number on top? Okay, there. I need to divide it by 12. Okay, there. Then I need to divide it by that. I'll just hit divide again. Natural log 1 plus 0.12 over 12. Okay. So I get 5.8. Okay? 5.8. What's this? 5.8 years. The time is in years. All right? Okay. So I guess we've done most of it at this point. But I don't think I gave the answer in exactly the form it was looking for. All right, so let's see. It says how long in years and months. Okay, so you could say like this was 5 years and 0.8 years. 5.8 years. That does not mean 5 years and 8 months. Okay? How is that? Okay. What 0.5 years? Like take 0.5 years. How many months is that? That's 6 months. That's half a year. So the way you can convert from some decimal number of years into months is take that decimal, multiply by 12, and if you do 0.5 times 12, you will get 6 months. Okay? So let's do this. To give this answer in the form as specified, in years and months, this will be 5 entire years and 0.8 times 12 months. Okay? So I have to take this decimal portion, 0.805, all that, and I've got to multiply that by 12. So here's how I'll do that. I'll take this number, I'll subtract the 5. That will leave me with just the decimal. If I multiply that by 12, it gives me a month's value for that decimal. So I get 9.6. So it's like 5 years and 9.6 months. So we will probably round our answers. The question should always say how we're rounding. And say we round to the nearest month. So we say 5 years, 9.6 months will be 5 years and 10 months. Okay, so 5.8 years is actually 5 years and 10 months. All right? Okay, so that's how we handle that one. It should look like the last one, but it might surprise you how we convert this decimal number of years into months. But that's what I spent this last part here trying to tell you. Okay? All right. Let's see. I think I had one or two more. Okay. So let's do this one, and I think that with this we'll probably have the lesson covered. All right. Okay. So it says calculate the rate required for the investment given in the table to grow to the specified amount. So if you take $5,000 and it needs to grow to $2,000, say that's your objective, you're going to compound annually. The investment's going to sit for 25 years. What's the interest rate have to be? So in the last one, it was sort of arranged like this, except for the time was the unknown factor. And now it's the interest rate. But nonetheless, I want to start with this and end up with that and figure out how to make it happen. All right? So I've been doing these by saying, okay, here's our operative formula. We take our principal, 1 plus the interest rate. N is how many times per year you compound. T is how long the money's invested. All right. So we're ending up with 2,000. We're starting with 500. I don't know the rate, but I'm compounding annually. How many times am I compounding the interest? 1 time per year. So N, the number of times you compound the interest per year, is just 1 in the case of annual compounding. All right, and I do that for 25 years. Okay, so I got everything there. 2,500. I don't know the rate. I know I'm compounding annually, 1 time per year. Investment sitting for 25 years. Okay, so I wrote all that down. I put this one there. Do I need it though? I put it just because I wanted you to see that that number N is a 1. But I don't really need it because, well, what is R divided by 1? It's just R. We don't really need the 1, so I'm going to just omit it and say 1 plus R. Same thing up here. I put 1 times 25. I don't, N is 1, that's why I wrote it down. So when you're looking at this, you see that number is supposed to be 1 in this problem. But I don't need it there. I can just put 25. Okay? Alright, so this time I'm trying to solve this equation for r, right? Okay, so let's see, let's divide this into that, to consolidate those numbers. So suppose I divide the right and the left by 500. 2,000 divided by 500 is 4. So I will get this. Okay? Alright. And I don't know, that might look strange to you, so let me try to give you an analogy real quick. Suppose you were solving x to the third power is 8. Okay? What do you think you would do with this 3? How would you apply this 3 over to the other side to solve for the x? Well, if that's the third power, then it would apply over here as the third root. And then we can either realize that the third root of 8 is 2, or we could use our calculator. Alright, but the third power over here is the third root over there. That's what I want you to see. So here, what about that 25? I need to apply that power over there if I'm going to solve for the r. See how the r is inside that? I have to get the 25 out of the way. Well, the 25th power will be the 25th root on the other side. So this will be the 25th root of 4 is 1 plus r. And then to solve for r all the way, I'll move the 1 over. R will be the 25th root of 4 take away 1. Okay, so let's see what that is. It would be hard for any normal person to calculate the 25th root of 4, but your calculator should be able to do it. I have, so let's see, right, let me get it to focus. I can't tell if it's focused or not, but right there, I don't know, this is not working out. I don't know if you can see it, but right there, that's my key to do any like arbitrary root. And I would use it like this. The 25th root, okay, the actual key looks like that right there. The 25th root of 4, okay. And then I need to take away 1. And that tells me what r is, okay. That's that, what is that? That's that decimal number that goes in the formula, right? Remember how when we did these problems, I said like, we might say 6%, but the decimal we use is 0.06. Okay, so this is that decimal, okay? All right, so I'm going to say 0.0570. That's about what I get, all right? But what percent is that if you work backwards? Move that decimal 2 to the right. That's going to be 5.7%. Okay? The number in the formula, 0.057, is going to be said to be 5.7%. Okay. And that's the way that we would report it. We wouldn't report that because people talk in terms of percentages. We do the math in terms of the number, but we talk in terms of the percent. So we'll say 5.7%. The rate is 5.7%.